So today we are planning to have a gear cutting operation on a horizontal milling machine. So firstly I will tell you about the different main parts of the milling, this horizontal milling machine. So this is basically the spindle. You can see this is the spindle and this is the motor, and further you can see here the arbor. This is the arbor and this is the arbor support, and you can see the gear mill cutter is mounted on this arbor in between the arbor support and the spindle. So further you can see here this is the workpiece material, and this workpiece material is basically mounted on the screwed mandrel, and the screw mandrel is mounted between the indexing head and the center support. With reference to the axis of the indexing head, the center support is mounted. So these are the main parts, and this is the bed, machine bed. Okay, so this horizontal milling machine is having the three axes, X, Y, Z, in which the movement can be done. So this is the X axis movement. You can see here, this is the X axis movement, and this handle is for the Y axis movement, and this is for the Z axis movement. Okay, so after this, before starting the operation of the gear blank, so we have to determine the dia of the gear blank. So you can see here, we have today's operation, we have to cut the gear of 4 module and 22 number of teeth. So for that we have to first calculate the gear blank diameter. In that gear blank diameter, the formula is basically the mz plus 2, where m signifies the module of the gear and z is the number of teeth. So you can see here the m is 4 as per our operation, and the z is the 22. So you can see after calculation the gear blank dia comes out to be 96 mm. Further we also need to calculate the tooth depth, which is basically equal to 2.25 into module. So after you can see here 2.25 into 4, the total depth come out to be 9 mm. Further, for the circular movement after cutting one gear to the next gear, when we have to go, we have to calculate the circular pitch, which is basically 3.14 mm. So 3.14 into 4, we will get 12.56 mm, the circular pitch. So these are the three basic calculations which we have to do before starting the gear cutting operation. So you can see here the gear blank of 96 mm dia is mounted on the screwed mandrel as per the calculation, and we will cut it to the depth of 9 mm. Further, on indexing head, you can see the indexing plate. You can see here the indexing plate. This is the indexing crank, this is the indexing pin, and this is the set arm. Okay, this set arm can be moved like this for the further indexing calculations. So basically in indexing calculation we have to use the formula of 40 divided by n, where n is the number of teeth. What is 40 here? 40 is basically the number of teeth on worm gear. So this indexing plate is further connected to a worm gear which is having 40 number of teeth, and further you can see the numbers also here. The worm gear 40 numbers are there. So you can see here the 40 is divided by n. So n in our case is basically 22. So we normalize it to 118 by 22. Further, so this 18 by 22 is what? That means we need to have indexing plate of 22 number of holes, and on which this indexing pin could have one full rotation and plus 18 number of hole movement. So we have the three types of indexing plates. You can see here. So this is basically type A. So you can see the numbers here, 15, 16, 17, 18, 19, 20. So these are the numbers available on this indexing plate, and further we have the indexing plate of type C, So you can see the numbers here 37, 39, 41, 43, 47 and 49. And we have the third indexing plate of type B. So you can see the numbers here 21, 23, 27, 29, 31 and 33. So these are the three types of indexing plates available. So you can see from these calculations. So here, so type A is basically having 15 to 20 range, 15, 16, 17, 18, 19, 20. Type B is having 21 to 33, which we see here that 21, 23, 27, 29, 31 and 33 numbers are available. So, and type C is basically having 37 to 49. So 37, 39, 41, 43 and 47, 49 numbers. So these are the standard numbers available with us in these three indexing plates. So when we further normalize it to 9 by 11, so 9 by 11, the 11 number whole plate is also not available with us. So further we multiplied with a common multiple. So 11 into 3 and 9 into 3, 27 by 33 came. So 33 number indexing 33 number was available on the indexing plate of type B. You can see here 33 number was available on the type B indexing plate. So when we calculated this, we got 127 by 33. This number signifies that we have to do one full rotation of this indexing pin on the 33 number and further 27 holes. So you can see the calculation come out to be 127 by 33. So it means on 33 number hole on the indexing plate, we have to do one full rotation of the indexing pin plus 27 holes we have to move after the one full rotation. So here practically we will do now the movement on the indexing plate. So you can see first the indexing pin is fixed on the 33 number. You can see the 33 number on the indexing pin, 33 number, and this is the sector arm which is been placed along the 33 number, and you can see here the 27 number also. Yeah. Now we will do the indexing pin rotation. So first we will do the one full rotation as per the calculation to the 33 number. Further we will do the 27 number movement to the 27 number hole. So it means the gear is moved after cutting the teeth to the next teeth rotation. So if we want to now further move after that, after cutting that teeth, so again we will do the movement like that. So the sector arm is rotated first, then one full rotation to that hole, and then 27 number. So like that, in that sequence we will cut the number of the 22 number teeth on the gear blank. Okay. One more thing I want to tell, that the gear cutter, selection of gear mill cutter for the type of gear which we have to cut, so that is available as a standard in the market. So you can see we have selected the cutter number 5, which is of module 4, and it can cut teeth in the range of 21 to 25 teeth. So as our objective was to cut the teeth of 22, so it was within the range of this 21 to 25. So this gear mill cutters are available in the standard. So prior to starting the gear cutting operation, we have to set the gear blank with respect to cutter as well as machine X, Y and Z axis, and after that during the cutting operation we have to move the bed movement in X-axis direction for the feet. After that, for the circular motion of the gear will be governed by the indexing plate, and the depth of cut which we will give in the increments, like 9 mm cut is there, so we will give it in like 3 mm, 2 mm as per the cutting operation, and that depth of cut will be given by this Z axis. Now we are starting the machine. So here the machine is going to start now. So you can see the cutter is moving. Started the gear cutting operation. So here the x-axis movement, you can see we are doing the x-axis movement. So you can see here the cutter is being set with the x-axis movement. Now the depth of cut is going to be set. So here we have set the depth of cut. We have kept the depth of cut of 1 mm now for the initial. Now again we are going to set the depth of cut.